knuckleheads like me trying to work it. All right, so what do you see now?
We see the Earth. And that is a sweet, sweet Earth.
All right, we'll go back a couple of slides. Okay, so the October 21 meeting. Thanks, everybody. And this is the routine tonight. We're going to end up about 9:30 Australian time. Not sure what time that will be in New Zealand, but I guess it'll be late, 11:30 maybe. So yeah, the Space Association, we're a non-profit group. We do various activities, including our radio show, which is called the Space Show. It's broadcast out of Brighton here in Victoria, but it also live streams on the internet, and we have podcasts, and we do media interviews and alerts. We do specials. Andrew Rennie is the boss of that. He runs it as his full-time job now that he's retired. And we also do podcasts of that now. So you can just search up that podcast on the various podcast platforms called The Space Show, and you'll get it each week and trim down a little bit of all the stuff that's not relevant to a podcast and rebroadcast. So it's quite a good way to get that news. And also it actually gets picked up by global audiences, which is great as well. As a group, we've got, we mention this every month, we've got a limited supply of these Searching for Skylab Blu-ray discs available for sale. And if you wish to get one of those, there's only a couple left now. You can go to our website, space.asn.au, and click on that, order one of those, $35 plus shipping, and pay on credit card, and it'll be sent to you forthwith. You take care of it, chat. We also have a book called The Australian Space Book by Kerry Doherty. And hopefully we can be joined by Kerry Doherty next month. She's a space historian. She used to work, used to run the space exhibition at the Powerhouse Museum in Sydney. So, so she's done a presentation recently. We're going to try and get her to do that here. So she wrote this book, or put this book together in 2019 for the 50th anniversary of Apollo 11, and it goes right back to pre-Woomera days in the Australian space activities. So it's quite a wonderful book. Comes right up to the establishment of the Australian Space Agency, I believe. So it's a great book. $49 plus shipping, and as I say, we've got about 3 or 4 of those. As far as a group, we do engage with a lot of people in the industry or in the space interest group, including the Engineers Australia and Royal Aeronautical Society and other people. We've recently been in discussion with people from the Melbourne Space Laboratory based here in Melbourne, and they've got a few projects on the go at the moment. One is Skyhopper and the other one is Spirit. So they're basically putting together experiments and hardware to fly into space on nano satellites. So they've got a student program and a partnership with commercial entities doing space activities. So we're having very preliminary discussions with them as a group on maybe somehow working with the Space Association of Australia on a project down the track, but nothing's been decided at this point, and it's just all very preliminary, but just want to let you know, you might hear a little bit more news about that in the coming weeks, months, or years. All right, so that's enough for me. We are a non-profit group where we basically run on memberships. So we, as I mentioned, we have our radio show, we have our meetings, and we have our various other special events that we do with various marking various anniversaries, etc. Probably the most notable ones recently have been the 2019 50th anniversary of Apollo 11. We did an Apollo 13 one, and we've done a Skylab one, etc., etc. So everyone's really enjoyed it. So and it's been lots of fun. So if you like what we do, if you'd like to be involved in what we do, become a member, get on the committee, become president, take over and go with it. You know, we are very happy to have new blood involved and people with different backgrounds, and everyone's welcome. And once again, hopefully next month, the November meeting will be actually physically meeting in Melbourne here. So we'd love to see you down there for a meal and a drink. And the meetings are free for everybody. So come on down. All right, so on the topic of meetings, our formula is basically fourth Monday of every month, except in December. So that means the next month will be the next meeting will be 22nd of November, and as I've listed there, hopefully and probably will be in person at the pub down in South Melbourne. Once again, that's the Golden Gate Hotel. We'll send you all the details out by email. We can get our website, and then once again, December, we're not going to have it on the fourth Monday because it'll be very close to Christmas. We're going to be doing that at this stage on the 13th of December, which is another Monday, about the second Monday in the month. And we have in the past had trivia nights. We've been lots of fun. We've done those for the last 5 or 6 years now. I'm not sure whether we're going to do one again this year. I think I heard a while ago someone had put their hand up. Tim, if you're there, I'm not sure if that's the case. But anyway, we'll let you know well in advance of that what we're going to be doing. But they're always a lot of fun. And there we go. All right, and once again, the Golden Gate Hotel down in South Melbourne. It's a great place, really nice food and drinks and a nice atmosphere. We actually meet upstairs there behind the Golden Gate Hotel sign there. We have our own room with a bar there, and it's nice. We can sit down and relax and have a good chinwag. We always allocate about a half an hour of socialisation time, so you can go and have a chat with people that you may or may not know. So it's always good fun. All right, enough for me. I am now going to hand over to Joshua. If you're there, Joshua, I'll stop sharing my screen.
The audio's okay?
The audio's good for me. I got you. Okay, we're now muted over here.
Okay, cool. So thanks for having me. It's super exciting that you're open enough to have someone from across the ditch join the crew for a little bit of a chat. My name is Josh. I'm from a company you may or may not have heard of us called Dawn Aerospace. We got invited on the show due to some recent flights that we've been doing of a suborbital demonstrator that we've been building. But I thought today I'd take a step back from that and talk a little bit more about what we're doing as a company in a more holistic sense. So let me start with some stats about sort of who we are. So we've been around for about 5 years, growing pretty quickly at this stage, which we're happy with. I was the first non-engineer to join the company, and my official designation when I first joined was not an engineer, and I was tasked with doing all of the non-engineering stuff. So I was one of the very early people to join the team, and it's been a real joy to watch as we've scaled and grown, and we're now at about 50 people, split mainly across New Zealand and the Netherlands, and with a little bit of a presence in the US. So I've got 2 more months left here in Christchurch with the team here, and I'll be hopping on a plane with me and my wife and relocating over to US to kick into gear there off the back of a few successes that we've had. In New Zealand and the Netherlands, we have engineering, manufacturing, test, and we're pretty vertically integrated across the board. The main bit, I pulled this from a propulsion slide. So when I'm normally going out and selling propulsion units, we've put a bunch of hardware in space over the past year and got a bunch of customers from around the world that are starting to buy things. This here is a few little images. This is our first launch in September 2020 on the Vega return to flight over in French Guiana. Transporter 1, Transporter 2 from SpaceX with a couple of the vehicles that we had built propulsion systems for. This is the Deorbit Ion Mark II satellite carrier with one of our propulsion systems popping out back here, and then another one from Soyuz flight that we did. So Dawn, we're a holistically, if you take a 10,000 foot view of who we are as a company, we're a space transportation company. So we're founded to really do 2 things. One is get things up into space. Once they're up there, we enable them to move around and do all the things that they need to. And once they're finished, we want to help them return back down. Now, whether or not that's actually returning goods that have been manufactured or returning the spacecraft itself or whatever that may be. So we see space today at the same sort of convergence point that we were back in the early 90s with the internet, that, you know, we didn't know what was going to come, but we knew that something was coming. And, you know, fast forward 20 years till today, or, you know, every part of the life that we have is focused around the internet. Now, we may not have known that 30 years ago we'd all be sitting here together on a Zoom call talking about things, but, you know, this definitely wouldn't have been possible if we hadn't have had fast internet. And we see this as the same with the space industry at the moment. And our philosophy is that we don't know what's coming in the future in the next 20 to 30 years, but we know that things are going to have to get up into space, move around to do the things that they need to do. And then once they're done, sort of come back down. So I'm going to start here with the first of the three parts of our business, which is position. And this is on green propulsion systems that we're building for satellites. We very intentionally took an approach when we started the business to find a commercial product that we could start selling quickly and off the bat. And we found that satellites were really hamstrung, you could say. Either these big billion-dollar satellites that are going up, they've got, you know, huge hydrogen-based systems, and if you got the budget, that's cool. Just filling one of these things is $500,000 to put gas in the tank. But when you're building a CubeSat, and that's your entire budget for the build and also for the launch, it doesn't really make sense that you spend the same amount of propulsion. So these here are two of the products that we started off. This is a little Cubesat propulsion module that we've got with a little thruster in the middle, and this is a fully sort of plug and play thing that you can bolt onto the back of a CubeSat. And this here is a picture of the larger thruster that we're starting to build. So everything that we do is based off nitrous oxide and propane in a self-pressurizing configuration. And I won't go too technical on this, but what it really means is that systems are cheaper, they're lighter, they're smaller. They can use just normal propellants that you could buy from any industrial gas supplier. So they're not hampered down by export control or anything like that. And they're extremely simple. So the first two thruster sizes that we've started off here, this one here, we're calling the B1. This is a 1 Newton class thruster that you can chuck onto a satellite, and the second one here is for when you need a bit more grunt. We're calling it the B20. It's a 20 Newton class thruster. So just like it doesn't really make sense to try and tackle everything at once. And so we're very pragmatic on our approach, and we decided that the best way to get into the market was to start small. So this here is a picture of one of our Cubesat propulsion modules that we started building. We built this for the Hyper satellite, with the Hyper 3 and 4, and this was in partnership with a couple of parties, which included ESA, which was quite nice. And this really enabled us to get something built, put it onto a CubeSat, and send it up into space. This is a 3D printed single monolithic block. It's a bipropellant system. It contains both the fuel and the oxidizer. These are fueling ports here with some valves, and this little thing here is the thruster, which sort of stands in the middle of it. And this thing really is plug and play. You know, like we hand over an ICD. We talked about the different protocols that they need to connect into a CubeSat. It runs on a bunch of different sort of operators, so it doesn't really matter how you're building your CubeSat. It can plug in, and away you go. This here is, we can also, because we're 3D printing these, we can make the tanks to almost any size that you want. So this one here is a 0.7U module, and then when you want to get you know, more gas in the tank, we just start to print it out and expand the envelope here. So we've got these going up to about 2U. So this was good to start with, but it wasn't really what the market was demanding. And so we built a larger class of thruster, and this here's the B20. Yeah, so we do, let me just move this so I can see my full screen. yeah, we make these all in-house. We do all the manufacturing and acceptance testing and all that sort of stuff. Yeah, and this is an image of a few of the thrusters packed, ready to go. We ship them over for integration, which was in Italy at this case, and then across onto the launcher. Now, we've got 12 of these units here in space as we speak, and 3 of the other ones. But what that enables us to do, let's make that small so I can actually see. I put the slide in here just to show, I took this picture here last week. We're really getting an uptick of demand with these things, which is quite nice. And we've moved from what was batch production into a continuous production line. So we're outputting about 3 thrusters a week for clients around the world. And we can scale that to sort of whatever you need. So, if we just buy some more machinery and so on, then we can easily double or triple that. So what it's enabled us to do is have essentially like a configurable and modular system for satellites of any size, whether or not you're a 3U CubeSat or a 500 kg satellite or a big GeoBird. This architecture that we've designed all works in harmony, and then you can essentially plug and play these space-proven components. Sorry, I'll just take a drink. And build a customized system of essentially any size. They're pretty neat. They work in both hot and cold gas. So they're all ignition based. You put some gas through, open the valves, the igniter goes off, and you got thrust, which is pretty neat. If you want to have finer impulse bits, you just open one of the valves, you don't turn on the igniter, and it pulses through the same system as a cold gas system. The ISP that we're getting through this is consistent throughout the life. Because it's self-pressurizing, we don't have a blowdown system, which means that we don't need regulators or helium pressurants or anything like that. So it means that we can get a lot more into a smaller space. Cool. So as I said before, we've launched a bunch of these over the past year or so. The first Cubesat Propulsion module went up here on a deorbit satellite, and then we went onto the Hyper 4 CubeSat. We then started putting these B20 thrusters onto the deorbit satellite. We've got another one on the Hyper 3 here, and then another one on the deorbit SCV number 3, which went up in July. So we're pretty happy with the uptick that we've had so far. Whenever you take a new novel product to market, you've got to sort of jump the chasm, you could say. That last slide was really talking about what we've got here. Since proving the technology out in orbit, we're really seeing an uptick with production and sales going pretty well. So I'm pretty happy to be in a job at the moment. So yeah. It's been quite fun. So yeah, we're in production of 100 plus of these thrusters over more than 25 different satellites. And I'll just chuck the slide in here, which we put out last week, which is quite neat. New orders over the past 30 days is about 27 thrusters over 7 satellites. So we've seen a real uptick. And what's quite neat is that once all of these thrusters integrate into the satellite and they go into orbit, it should position us as one of the top, or the #1 green propulsion company in the world, and would have the most thrusters on orbit, only second to hydrazine, which is pretty cool for a New Zealand Dutch company that's been around for as long as we have. So we're pretty happy with this. And part of why we're making this happen is that we're a full service partner. So, we're not just providing a system or like here's your propulsion system, now you design your satellite around it. We'll sit down with the client and say, hey, what are you trying to achieve? okay, this is your satellite, this is the launcher that you're wanting to go on, this is the orbit, these are the things that you want to do, and then we'll do real systems engineering and design around all of that stuff. It will help them with the integration and all the logistics, and then sourcing of the propellant, and we'll put people on a plane and send them over and help with the fueling if it needs it. One thing that we're really happy with, we've in some cases figured out a way to actually load the propellant onto a satellite prior to shipping. So this here is us fueling it at the customer's facilities. It's fully integrated. It then goes into a deployer, hops onto a plane. That then got shipped over to the US and then over into Russia. And then all they had to do was take the deployer, put it onto the stack, and away it went. And then once it's in orbit, we help everyone with actually making sure that they've got the confidence, they know how to operate these things. And we go through a process of commissioning it with the teams and then putting them in a self-service state. So that's sort of what we're doing on position. Each of these different parts of the business have different phases. The position isn't just what I've showed you today. It's the first part of much of a larger vision. With everything that we do, we sort of take a far lens on and have quite a long outlook. And so we don't typically adopt a project unless we know that it's going to have legs of 10 years plus. So the first part of the puzzle of this deliver, position, return, and the second part of the business that we started working on was a launch system. And our goal is to have same-day reusable spaceflight from any airport, from any major city in the world. And so, again, we're trying to take very pragmatic steps in achieving that. And that's one of the reasons why we're down here in New Zealand. So this here is a operational diagram that I suppose everyone here would be familiar with. And it's how most rockets get to orbit nowadays. This is really a philosophy created by the Russians, which the US then followed in the Great Space Race back in the day. But this here wasn't the original means that the US were really looking at, and you saw that with development programs like the X-15. So we decided to take a step back from this operational diagram and look to history. And we've decided that the way that works for us is to build something that is entirely circular, almost completely reusable from the outset. And yeah, I'll just walk you through this here a little bit so you can get a feel of where the different vehicles play into this. So we want to do rocket-powered flight of essentially a plane. So what we're building is an airplane in every sense of the word. The only difference is that it's got a rocket on the end of it and it goes pretty high. So the first stage here is designed as a space plane. It carries within an integrated second stage and payload. This will then go up and deploy it round about the 100-kilometer mark. The first stage is then 100% reusable. It will turn back around, and then sorry about that. The second stage will deploy off, get to where it needs to go, deploy the payload, and then the second stage here will come down and deorbit, and the satellite will go off to where it needs to go, ideally with a little Dawn propulsion unit on the back of it. That first stage will then come back down, land at the same point as it took off, and we'll have here essentially a factory of second stages pre-fueled, ready to go, where we can drop this back into the aircraft, run some basic checks, refuel it, and away it goes. So, oh, sorry if that's a little bit loud. This here was the first stage of the plan that we had, and this was to show that we could put a rocket engine on the back of an aircraft and fly it multiple times per day. So this was the Mark 1. Every every aircraft that we do, by the way, is as small as we can possibly make it to prove out that concept. So this is quite a small vehicle with quite a small rocket engine on the back. But the purpose of this was to show fully autonomous flight, that it could fly under rocket power. We flew it 4 times in a single afternoon, and now it serves as the test bed for the Mark II. This is the Mark II. Let's move this over here. This is the vehicle that you may be more familiar with. It's a suborbital concept demonstrator. And first and foremost, this is our own piece of equipment that we're building for demonstrating essentially the first stage of the operations that we showed before. It's designed to fly up to 100 kilometers altitude, get about 3 minutes of microgravity, turn around, come back down to the airport, gas it up, we fly it again. So this is the vehicle here. In every sense of the word, we're trying to do things like an aircraft. So it's certified as an aircraft under, at the moment, a Part 102. It's got wings, it's got landing gear. It's got a boom on the front here at the moment for measuring just some stuff for the avionics. And at the start, we are flying it under surrogate jet power. So the purpose that we're doing at the moment is to test out the airframe, because it is a novel airframe, a novel avionics. We've got all of the communications protocols that we're doing, all of this is novel as well. So making sure that we don't have an experimental rocket engine on the back. That's just one piece of complication that we decided to take out for the time being. So we're doing a real build-up approach here, where we test a little bit, we make sure that that works, we move on to the next bit, we test that that works, we move on to the next bit after that. So having a reusable launch vehicle at the end is a really great thing. But what's even better is having a reusable vehicle that we can test each little bit multiple times per day without having to throw it away each time. So that's the philosophy here. What do we got here? This here is a video that you may have seen before. This is a cut of 5 different flights, which we did down at Glentana Airport. So this is one of the air. And the idea is that we're not restricted to any one place, but we have the option to move around different places as we go. So this whole launch system fits in the back of a trailer. In the back of the trailer, we have the ground control. We can essentially turn up to any airport and within 1 hour be flying. We put a generator out, we put the antennas out, we roll it out, we run you know, safety checks and everything, and then we go flying. I must say it was a bit of a buzz to see this flying for the first time though, so that was pretty good. And it's a stunning landscape to be able to do it from, and it's about a 4-hour drive from home. So yeah, we're pretty lucky to be based down here at the moment. So we won't be flying under jet power forever. This here is the engine that we're going to be plugging onto the back of it. And again, it's designed to be completely reusable. So, you know, as we use it, the engine shouldn't fatigue. It's designed to operate up to more than 1,000 flights with a bit of maintenance in between, but it's been designed as well for air-like operations. So the whole thing is high test peroxide and kerosene. The reason we chose these propellants is that they don't boil off. Now they do have a lower ISP than most people would say, you know, compared to LOX engines or anything like that. But when you think about it, we don't have to, you know, because we're not throwing the whole vehicle away, and because we're doing a a glided landing. We don't have to have a whole bunch of propellant on there to do a propulsive landing, and it means that we can take a bit of performance hit there. So the operating life of this is definitely in the hours. It's pretty cool the way that it works. It works in both monoprop and biprop mode, and it's highly throttable. So it works just like a jet engine that a pilot can sit there and turn it up and turn it back down sort of as needed. Again, I might just play that again because I really like this video. Yeah. Yeah, cool. So that is the, I brought back to this this operational diagram a little bit. When we attach that rocket engine onto the aircraft, we start flying it, it's really to demonstrate this first part here. Flying up, going above 100 kilometers, turning around, coming back down. Now it does have space for a payload if needed, so nothing will get deployed at the moment, but there is essentially room for a 3U CubeSat on board where we can host a multitude of scientific experiments with, you can plug in power, and there's a data downlink and stuff like that. And then we've also got a bunch of atmospheric sensors in the nose cone, which means that as we're flying up, we can do atmospheric research on, water vapor and temperature and ozone levels and all that interesting, cool stuff. Now, we're not really releasing exactly what the Mark III will look like at the moment, but there is another vehicle after this, and it is a two-stage to orbit vehicle. It's about the size of a business jet. This is me next to the Aurora, and you can see that it's pretty small. This is the smallest we could essentially design this rocket with wings to be able to make it, kiss space and come back down. But once we prove that out, then we have this next vehicle coming underway. So this will be a lot bigger. It's about 5 times the size. And yeah, it's designed to take a 250 kg payload. We've found that 250 kgs with analysis of what we're doing with satellites is really the sweet spot. For small satellites, you'll be hard pressed, except when it's like a very large government or mainly government or military payload that you get above this. But our market is really focused on LEO operations and of the small sat commercial market, which is where we're selling most of the propulsion systems into now. So we think that with this payload, we can service quite a large portion of the market. And with the frequency of flight, of being able to fly the same vehicle multiple times per day, then we can really start to hit into that mass to orbit that really you need to get to if you're going to be a viable long-term operator in this market. So yeah, this comes back and shows how it operates again. And then the last part of what we're wanting to do, which we don't talk about too much at the moment, but there are some critical plans here, is return. So there was an interesting stat that I think a year or two ago, 98% of space flight was one way. But if you want to have a bustling space economy, trade really needs to be a two-way thing. Space can't just be a one-way destination. So we're building the technology to be able to bring things back down from the assets and infrastructure that we're putting up there and return them back down. And I found this photo today, which was super cool, from over at the Kennedy Range in Australia, and I thought it was kind of fitting for today's call. Yeah. It wouldn't be my job if I didn't do a little plug. We're hiring. We're growing quite rapidly on a weekly basis. So we're growing at 1 to 2 people a week now. We've got people from quite a diverse range of backgrounds, and also from a lot of prestigious different companies in the industry, which is quite neat. But if you can think of it, we're essentially hiring for it, both here and in the Netherlands. So that would be cool to pass this around. I think we're not a bad bunch of people as well. And I think one of the things that we never tell people until they join is that we've got a weekly barbecue every Thursday. So if you like free food, and we put on lunch. So it's always a cool thing. And that's me. That's the end of the presentation. So see a couple of questions in the chat box. And yeah, do we do Q&A now, or do you want to do it afterwards, or how do we run this?
Peter, do you want me to allow people to unmute and they can start talking?
Yeah, I saw 3 questions here. Notice the wing design is similar to the shuttle. I believe so. The airframe has been designed mainly for high lift, so to get up as quickly as possible, and as soon as you get out of the atmosphere, the wings don't really matter. And then it's designed to be able to really slow down in the far upper atmosphere. So I think there's inspiration from the shuttle, but like I said at the start, I'm not the engineer. I couldn't quite tell you on that one.
So you've got the part of your company's in the Netherlands. So what part of the business do they run? Do they just send you boxes of money, or is it more than that?
I wish. So the parent company is based in New Zealand here. However, most of our clients, there's not too many satellite builders or large satellite builders down here in New Zealand. There's quite a few popping up in Australia, which is good for proximity. And we're talking with quite a few of your local companies over there. But majority of the customers that we have at the moment are based in Europe. So we're doing a lot of systems engineering over there, customer interaction. And the company, or the founders, actually met over in Delft, which is a real aerospace hub. And then it was a later decision when we found a lot of difficulty trying to find somewhere to fly. It's very easy to build subsystems for satellites in Europe, and there's a wealth of knowledge there, and it's a great place to find some really smart people. But it's very difficult if you want to build a novel aircraft that flies under a completely different rule set to find anywhere to actually do it over there. So the New Zealand Space Agency and the New Zealand Civil Aviation Authority have a very progressive outlook on the way that they do certification. So we moved the business here, early on. So it is a 50-50 split at the moment.
Yeah. Okay. So just a couple of questions on your thrusters. You got the B1 and B20. Are they your own design, and are they produced by 3D printing or part thereof?
Correct. Yeah.
Yeah. Yeah. Okay. And and the fueling, you're saying you can ship those actually fueled to the customer, and they can just bolt it on. So what if they want more fuel, or do they just tell you how much fuel they need? And
so typically what we'll do is we'll ship not a fueled propulsion system over to the customer, because they need to run a bunch of integration and functional testing. So hooking their computers up to it, opening and closing valves, making sure that everything works as expected, running through different sequencing of the propulsion module connected into the bus. But when they've finished that testing and they're ready to then box it up and ship it to a launcher, then we can do fueling. And we also supply the equipment to do fueling for the customer, so they can take complete control of it themselves. They don't need us turning up whenever they need to do it, which works really well when it comes to functional testing of the satellite pre-launch. So these thrusters work in both vacuum and ambient conditions, meaning that they can connect it up, they can put some propellant in. They're super safe. The propellant, you don't need escape suits or millions of dollars of infrastructure to deal with it. You can fire it, make sure everything's going good, and then once they're happy, they can package it up and ship it off.
And you mentioned they were self-pressurizing. Is that how you termed it?
Just like it's like a barbecue gas bottle. You turn some on, you cook some snarlers, you turn the gas off.
Right.
You don't have like
gradually
something
decreases.
pushing the gas out.
Right,
Yeah.
right. Okay, I've got a couple of questions. You've probably seen them yourself, but do you have competition in this field? I assume they're talking about the single stage to orbit aircraft that you were presenting just a moment ago. I guess there's a lot of competition in that area, not to say the least. Rocket Lab down the road.
Yeah. So, just a small correction there. Like what we're doing is not a single stage to orbit. So the first stage of the launch vehicle that we're building will never be orbital. It's the Mark II that we're building is suborbital, and then the first stage of the Mark III is exactly the same as the Mark II, just bigger. So that will fly up. It will deploy a second stage at circa it's about 85 kilometers or so, and then it will depart and turn around and then come back down, and then the second stage will boost it off to where it needs to go. The first stage actually follows a near on exact same flight profile as a Falcon 9 rocket. It just doesn't take off or land vertically. It's a horizontal takeoff and land.
So is this a plan for you to run this as an orbital service, or are you simply planning to sell the kit to other customers that run their own operations, or a bit of both?
Oh, we'll be running the service ourselves.
Fantastic.
Yeah.
So obviously being an aircraft back from relatively high speed and high height, you'd need to have some heat protection tiles or something on the aircraft. Is that correct? Or
no, it's just like if you think of the spaceship too, it's not reaching the velocity that the shuttle would be reaching. So
yes, course,
because it's not an orbital velocity and it's only a suborbital profile. There's heat shielding built in, not through traditional tiles or anything that you'd expect to see, but through different types of resins that we use on the vehicle. So it's not reaching the same type of velocity that you would from an orbital vehicle, so it doesn't require the same type of heat shielding.
We've got a question. Are you any plans to go public share offering, an IPO?
I don't know.
I don't know. Above your progress. Okay. After your first B in, yeah.
Yeah. Well, we've been pretty lucky with the way that we've grown the business. We haven't even done a Series A yet. A lot of the business is funded by the propulsion sales that we're getting from different grants that we've been doing with various agencies, and we've taken quite small intentional steps to get to where we're at, where we don't have to go out and raise a lot of money until we've proven that our mode of operations is actually going to be feasible, because what we're doing is quite different. So instead of us going and raising a bunch of money and then investing all that money into a decade-long development program and then having something at the end of it, we've decided to build a business in every step of the way, and that's tended to fund itself.
That's fantastic.
We do need people that can talk Dutch. Half the company's Dutch. One of the questions.
I only do that after a few drinks. Can the B-20 be incorporated into a rocket for maneuvering thrusters? I don't know what that means. Can it? I guess it. Does it meaning can it use to launch a vehicle out once it's? Malcolm, could you? Yeah, thanks, Malcolm.
Yeah, part of our design for our rocket, we want to be able to maneuver the vehicle around in orbit to position satellites. And I was wondering if we'd be able to incorporate the B-20s into the actual design to give us small movement in space to get a more precise deployment of satellites.
So as an RCS system, definitely.
Cool.
Yeah, we're doing that for a few projects, and it's definitely something that they're good at doing.
Cool. I'll have to get your details so I can get in touch with you.
Yeah, cool.
Thanks.
There's a question here, if I'm not wrong, satellites orbit at a height from about 160 kilometers makes altitude of the Mark II 110. So the Mark II will never put a satellite into orbit. It's entirely suborbital, so it'll go up to 100 kilometers and then it will stop and it'll come back down. And then it is the next generation vehicle, the larger one that we're building, that is designed to be provide that orbital service. And the maximum velocity of the first stage about Mach 3.3 ish, and that's on the descent.
And so, do you have an automated system to fly it, or is it piloted from the ground in some extent, or is it fully automated for
so
the payload's deployed and landing?
To be ambiguous, it's both. So the vehicle itself is being certified as an RPA or UAV. So it's a remotely piloted aircraft where there'll always be a pilot sitting there. However, majority of the flight is autonomous and, you know, different to having and I know it's not actually like this, but like a big red termination button where if something goes wrong, blows it up, and that may be just like, you know, cutting the engines off once it's out of range. And who did that? I think it was Firefly on their recent launch. You know, they launched and there was an anomaly, and they cut the engines off at a certain altitude, I think. Maybe that was Astra.
Yeah, Astra went sideways, didn't they?
Yeah, but then it went up, and then I think they turned the engines off.
Yeah.
We've got a pilot that can essentially take over and manually fly it back, and the descent that we do of the vehicle isn't actually rocket powered. So, you know, you've got that full control like you would of an aircraft to be able to come back and use the control services to do a safe landing.
So Michael, who's sitting beside me here, is asking, can you say something more about what the particular is considered green about the propulsion systems you're using?
They don't kill you.
You have to kill us. Okay.
Yeah. So green is like they're not. The status quo at the moment is a fuel called hydrazine, and it's been around for well over 50 years. I'm assuming you would have heard of it. It's got all these great properties that make it the near perfect propellant for space. You know, it's near and infinitely storable. It's the density of it's very good with a whole bunch of other things. However, it's highly toxic. So that's why when you want to fuel a satellite with hydrazine prior to putting it onto a launch vehicle, depending on the launch site, if you're here in New Zealand, you'd ship it far away from the launch site to a sort of blocked off location. You'd do it all off site and fuel everything with minimal people around and put it back into the vehicle. If you're in other places like French Guiana, for example, you shut the entire launch site down for 3 days while everyone vacates, and you wear scape suits and everyone looks like they're walking around from ET, and you plug it in and away you go. Green means that it's not highly carcinogenic. It's not going to cause adverse effects to the body.
And what about the exhaust of the thruster or the vehicle? How does that go in the greens sort of qualification?
Pretty good.
Yeah.
So of the launch vehicle, the exhaust fume is just steam and water. It's just water. The emissions from that per flight is essentially equivalent of about half a tank of gas of your car. And then, yeah, for the, I'm entirely too sure what the emissions are for the propulsion system. I'll come back and I'll come back to you on that.
It's okay, no problem. I've probably got time for about one more question. To keep in mind, everyone, that Joshua is in New Zealand. It's just about 10:30 over there, so we're going to let him go very shortly. One more question if anyone's got one. And Joshua, would you mind if we shared some of your contact details with the group? We'll probably pop in the chat
go
here.
for
Is
it.
that okay? Yeah, fantastic. All right, well, without another question popping through, and to let you get back to your holiday in New Zealand, we'd like to thank you so much for joining us. I'm been blown away by this presentation. It's fantastic. I didn't realise it was quite as diverse. I'd seen the unmanned aircraft, but I hadn't heard anything about, my fault, I guess, about the thruster side of it. And that sounds like it's a real core of the business at this point. And it looks like you're doing a lot of great things there. So thank you so much for joining us.
Yeah, thank you for having me.
Keep us in mind with the next sort of stages that you're working through. We might have you back again. And once again, if you're ever in Australia, in Melbourne, come along and have a beer with us. It'd be really good to see you.
Yeah, I'd love to. Yeah, thanks for having me. I'll sit in for a little while and put myself on mute, but then might politely drop off and then catch the rest on YouTube later on.
Fully understand. Thanks again, Josh.
No worries.
All right, so now we're going to pick up the rest of the program. We're going to have some Australian space news here. I just got the most appropriate presenter to show you to guide us through the segment. So we've got quite a bit going on. I haven't captured everything, and there's so much going on. I've just had to sort of compress a little bit, but we'll go through. So Lear Labs will construct radars in Western Australia. There's a lot of stuff happening in Western Australia, you guys over there. So they're going to construct 2 phased array radars in Western Australia, which will be the 6th site for the company in its worldwide space tracking network. So the West Australia Lear Labs site was selected in part because its longitudinal provides the view of launch trajectories from Asia. It's interesting, and also help Lear Labs observe satellites and space debris. So that's a big part of what they do as well, traveling over the southern hemisphere. So, and they are recruiting employees in Australia. So if you're in WA or you want to get a job with Lear Labs and in WA, get on over there and find out what's going on. It could be quite interesting. So this is a picture of one of their facilities. I believe this is in the US somewhere. So we've had fewer of these space tracking radars and optical telescopes in the southern hemisphere. Northern hemisphere is obviously much more covered. So that's one of the reasons why the Air Force authorised Lockheed Martin to survey Western Australia for the 2nd Space Fence, which is a ground-based S-band radar system to track objects in orbit. So it's the 2nd southern hemisphere site. There is also one operating in New Zealand to detect objects in low Earth orbit, as small as 2 centimeters in diameter, which is pretty amazing, isn't it? So there you go. I never knew this was going on. So this is kind of a concept of how it would cover. You can see on the right-hand side, the New Zealand facility covering that segment, and now the Western Australia segment will overlap with the New Zealand segment to be observing those objects in space. So that's quite interesting. The AUKUS Pact will deepen Australia-US collaboration in space technology. So we've probably all heard about the AUKUS agreement, which between the US, Australia, and the UK. Enrico Palomo was on a conference with Bill Nelson and some other worthy people, include someone from Lear Labs and Equatorial Launch, etc. And they were discussing Australia's role in an ex-crewed mission to the moon known as the Artemis Mission. So the role of AUKUS was glossed over initially as announced about the funding at the ending of a submarine deal with France and their submarine deal. So in favour of the nuclear submarines from the US or the UK. So that got all the headlines, but this is part of that progress. So Nelson spoke about Australia's long-standing alliance, etc., in wars and space exploration, the Apollo program, etc., and NASA was preparing to announce more details about our role with the Artemis missions. So he's been saying, as you said, we've been partnering with Australia for quite a long time, identified an opportunity that will enable Australia's expertise to align with NASA's exploration capabilities. What have we got there? It's going to be a great partnership. So then they asked Enrico about that. Oh, sorry, I've got the wrong words there. There we go. And he said, stay tuned. Enrico Palama being the head of the Australian Space Agency, as people may or may not know, he used to run Virgin Galactic in the States. He's an Australian guy. And we believe this is what he was alluding to. So Australia will provide a rover for future NASA lunar missions. So the Australian Space Agency and NASA announced in October that we will provide a rover on a commercial lander mission no earlier than 2026. So people may or may not recall we were pretty involved, the Space Association that is, in part of a group of organisations trying to push the Australian establishment of the Australian Space Agency. One of the things was the ability to strike such agreements as we're seeing here. So it's really coming to fruition now, which is really fantastic. So the Artemis mission, the lunar exploration effort, and part of the test resource of utilisation of technologies, etc. So this rover is going to weigh no more than 20 kilograms and scoop up lunar regolith and return to a lander, depositing into an in situ resource utilisation experiment on the lander. And that payload will then attempt to extract oxygen from iron and silicon oxide compounds. So the rover is part of the Australian program called Trailblazer, and the flagship element of the government's Moon to Mars initiative, which was announced back in 2019, which is, well, when the state agency was established. So the Australian government is committing 150 million Australian dollars to that initiative over 5 years, and using expertise such as mining and robotics, etc., etc. Near the Australian space, let me give it just a second. Australian Space Agency or NASA disclosed many details about the rover, so we'll keep an eye on that and we'll let you know as soon as we know anything. The agency said that it'll provide additional details about the mission later this year. Now, we're the Space Association. We have a lot of contacts and inside information about upcoming projects. And we've got a worldwide exclusive here. We've got a preliminary design schematic of the Australian rover, and I'm about to present it to you now. Looks very retro, but I'm assured it's very reliable. Sorry about that, guys. Dad joke. Registration for the Southern Space Symposium 2021 is open, which this symposium will be held 29th to 30th of November in Canberra. So it's in partnership with the Australian Space Agency, and it's the industry's flagship annual conference. At a pivotal moment, they're saying, this will be a year to bring space industry together with government, parliament for 2 days in Canberra. And the participants will include federal government departments, agencies, international agencies, etc., etc. A lot of companies, a lot of small startups, etc., and individual space professionals. So should be quite good if you can get there. So speakers at this stage will be the Honourable Melissa Price, the MP, the Minister of Defence Industry, Science and Technology, Mike Pezzillo, the Secretary of the Department of Home Affairs in the US, Enrico Palermo, as we mentioned him, he's the head of the Australian Space Agency, and there'll be other speakers announced shortly. So it'll be available for delegates to both attend in person or online. So just do a Google search and you'll be able to track down those information. Excuse me. 500,000 Australian dollars will be allocated to 5 projects under the Australia-UK Space Bridge project. These first investments under this UK Space Bridge, Australia-UK, have been awarded to 5 collaborative research projects in areas of Earth observation, agriculture, space communications, and quantum technologies for space. So it's part of the SmartSat CRC, which is supported by Austrade, the agency, UK government, and the UK Space Agency. So once again, more evidence of this partnership, of the globalisation of this network that we're developing as part of having our own agency, which is fantastic. So they were respondents to this were required to address 4 topic areas, and those topic areas being, and these are the awarded people: the Calvel Space Bridge, the Earth Observation Partnership with those companies, establishing commercial opportunities for Earth observation, calibration and validation, modelling novel radio spectrum bands for next generation satellite networks, stability of next generation satellite communications, etc. Ice Cube, monitoring Antarctic sea ice with small satellites. So UNSW, University of Tasmania, etc., has been involved with that one. And Australia's quantum leap to satellite quantum encryption. So this is quite interesting, preventing cyber attacks on future financial encryption services. So that's a very topical subject at the moment, of course. And harvesting hyperspectral satellite data to improve crop production. So obviously quite important for the world and for Australia in particular as well, with our agricultural area. So that's part of the University of Adelaide and other partnerships there. So very exciting. Moving up to Northern Territory, they're investing $5 million into the Arnhem Land launch facility. So the NT government will make this investment, and it will mark the first time for NASA launching sounding rockets outside of the US from a commercial facility. And this will be at the Arnhem Space Centre. Chief Minister Michael Gunner, the Chief Minister of NT, was at the site last week with the ELA and NASA personnel who've been preparing for the launch. We mentioned this about a month ago, I think, where they'd just came out of the 2 weeks quarantine from the US. And so they're quite excited. The head of the Sounding Rockets Program Office, Scott Bissett, said, as of today, we officially have our medium mobile launch installation on the Equatorial Australia launch pad. So, so they've been preparing for those for that facility. Tracking systems and other systems need to be set up when they return next year. So that's great. Look forward to seeing some of that go off. So it is a commercial facility up there. We talked about those facilities. There's other facilities down at Wales Way in South Australia as well. So there's a bit going on in that field as well. So that's good. That might be of interest to the Dawn guys over there, if you're still there, Josh. This standing rocket program will be involved in astrophysics research, etc., etc. So this is a mock, like a conceptual design. Well, I think they've actually started construction. This is a rendering of the final design. There we'll have 3 launch pads, and that is a picture of one of the NASA officials and I think the Northern Territory minister. All right, that's it for Australian space news. We're going to zoom straight into international space news, global space news, and here's our man Richard William Shatner. That was just after he did his suborbital flight with Jeff Bezos. So South Korea's first homegrown rocket reaches orbit, but fails to get the dummy payload into orbit. So this was this last week, 21st of October. Its 3rd stage engine unfortunately shut down 46 seconds early. It just had a dummy payload, so there was no real loss of IP or a great deal of loss in that, but obviously it was a test flight, and the good thing they had a dummy payload on there. It is expected to fall back to Earth south of Australia, so I assume that's already come down. So I guess hopefully it's just landed out in the water somewhere and no one's been impacted by that. It was a nice launch. So this Nuri flight, the president of South Korea, Moon Jae-in, announced the flight of the Nuri is complete. I'm very proud of this. Regrettably, it didn't reach the goal it aimed at, but it lifted off 4 AM Eastern time, carrying 1.5 kilogram dummy payload. So it got up, did most of the objectives of the mission, not all of them. So I guess they'll be looking at what went wrong and cycling up to get going to the next one. So good on them. There's a lot of launch launch facilities and people getting into the small launch area at the moment. So, yes. All right, so over to the US, the Artemis 1 Orion space capsule joined up with the SLS to complete the vehicle stack. So that took place. It was listed on top of the SLS rocket on the 20th of October, which completed the major assembly of the full vehicle stack. So you can see this graphic here showing the different steps. First of all, they built up the solid rocket boosters, which are, for those people who don't know, derivations of the shuttle rocket booster with an extra segment in them. Then there's the tank and the interstage, the second stage or third stage, I think they call it, and then finally the capsule with its abort system on top. So that's up on the stack now in the vehicle assembly building, and it will be going up shortly. I've just got a quick little video. Hopefully it'll run for you nicely. It only goes for about a minute. Just I've sped this up. Can you hear that? Oh, you know, listen. What can you hear? No. So for those people who don't know, the vehicle assembly building was built for the Apollo program, and they stacked all the Apollo spacecraft and all the shuttles in that building, and now it's being used for the SLS. All right, so so recent forecast for the launch readiness for the first flight is looking at January 2022 for the flight readiness review, and a 2-week-long lunar launch opportunity will begin in February. So Mike Serafin is the Artemis 1 program mission manager, and so now hopefully we'll be able to travel overseas by then. But if start calling up your travel agent, maybe you can get over there between the 12th of February and the 27th of February. And if it'll be the first opportunity, it will take place at 5:56 p.m. on that day. So get on over there, get your hotel bookings now. At the start of a 21-minute window. Additional launch opportunities will be from March 12 to 27 and April 8 to 23. So I don't think I'll be booking my flights just yet, but that's we'll see how we go. So this is the mission profile that the Artemis 1 vehicle is going to undertake. It's kind of an Apollo 8 type mission where it'll be going up, swinging around, going to orbit around the moon and then coming back. I think it'll be about 2 weeks. And it'll be good to see. Hopefully it gets off all right. It'll be a spectacular launch to see. There's 4 space shuttle main engines, the 2 solid rocket boosters. It'll be make a heck of a bang going off. Hopefully it just stays together and goes into does a bang in the right direction. So yeah, that graphic is quite comprehensive about what the different parts of the mission will be. So it will insert itself into lunar orbit and eventually make its way back to a splashdown. Looks like it's going to be off the coast. Oh no, where's it going to go? Oh, I don't know where they plan to land. Splashdown, Pacific Ocean. There you go. Just over there, just in our backyard. Good luck. Okay, so some more US news. The Senate directs NASA to choose another company to build the lunar lander. Back in April of this year, NASA did announce that SpaceX alone had won a final competition to build the next moon lander for the Artemis program. There was Dynetics, SpaceX, and National Team, which comprised Blue Origin, Lockheed Martin, Draper, and somebody else, with their various concepts for a lunar lander. SpaceX won that competition, and supposed to be going to by 2024, but we're 2021, almost finished that, so I don't know whether they're going to make that, but anyway. This date did come as a surprise, as many expected the agency to choose 2 or 3 companies vying for the contract, which is a normal case. However, I think because NASA's so tight with money, tight with the budget, that they really couldn't afford to have funding multiple different tracks. But after much legal back and forth following NASA's original decision, the Senate Appropriations Committee, the largest US Senate committee that oversees all discretionary spending legislation, is directing NASA to now choose a second company to develop a crewed lunar lander. However, they only gave them a very, very small amount of extra money to fund that. So I don't know how they're going to go doing that. So the original decision to grant this landing system was met with staunch protest by the other 2 companies, of course, and particularly by Blue Origin. They filed formal protests, and Blue Origin even wrote an open letter to NASA administrator to request a contract offering to cover up to $2 billion of the cost. So I don't know why he didn't just discount his original price for $2 billion, but anyway, this didn't work, and the company went on to file a federal lawsuit against NASA, a legal choice that put HLS development on temporary hold. So anyway, we just watch this space. Blue Origin may get switched after all, who knows? But without NASA having a lot more money to fund 2 programs, it's going to be pretty tough. Maybe Jeff will just fund his own. Now, Boeing has some more trouble. NASA and Boeing are testing the valves to confirm the root cause of the Starliner's issue. But people are not aware, Starliner was one of the 2 human landing, capsules or human vehicles for servicing low Earth orbit, to going up and down to the space station, essentially. Obviously, once a space shuttle stopped flying, the only option at that stage was to use the Russian or the Russian Soyuz. NASA put out a contract proposal or a request for a proposal for a human on orbit system. So the 2 final winners were awarded contracts: SpaceX and Boeing. Now, SpaceX was given about half the money that Boeing were given. SpaceX has now had 3 human flights up into space using their Dragon capsule. I think 2 of them have rendezvous with the space station. The other one was a kind of a joy flight. Boeing haven't had anyone up there yet. So they're saying that they had a problem with their vehicle because they had some excess water and humidity causing valves on their vehicle to stick in the service module. They plan to extensively study the problem, and hopefully they will be launching again in 2022. So it's actually redoing its original test flight at its own expense, following an uncrewed Starliner mission back in December of 2019 that went awry due to software issues. After a successful uncrewed test flight, Starliner could fly astronauts sometime later in 2022. So they're not doing as well as they'd hoped, obviously. So they hope to try again in August of this year. However, these problems with the sticking valves cropped up a couple of hours before the actual flight was to take place, and they were not able to go. So they said 13 of the 24 oxidizer valves did not behave properly, sticking in the wrong position. So while it's still on the pad, so they were able to free up 9 of them, but 4 wouldn't move correctly. So that prompted Boeing to return the Starliner back to, well, originally back to the vertical assembly facility, but then they decided to destack the whole vehicle and take it back to the workshop and see what the hell's going on. They end up using that Atlas rocket for the Lucy mission, which happened last week. So some flow on from that, Boeing thinks that some of the oxidizer inside the valves actually escaped, leading to stickiness. The valves are sealed with Teflon. It's known that oxidizer can sometimes permeate through Teflon material. So if they do fly the Starliner in the middle of next year, the company hopes to fly the vehicle with its first passengers toward the end of 2022. Now you see a picture here on the right-hand side. That's the latest generation of astronauts. Essentially, the 4 guys on the right have been trained to fly the SpaceX Dragon, and in fact they've all flown, and the 5 on the left were going to be flying the Starliner. With the delays to the Starliner, NASA has now reassigned Nicole Mann and Josh Cassada from Starliner over to SpaceX to give them some flight time. So that's the two of them there highlighted. So they'll be going a SpaceX capsule up to the ISS late next year. Anyway, we do hope that Boeing gets it sorted and gets it going. So over to SpaceX, Elon Musk says the Starship may be ready for orbital launch next month. That's, well, November. However, the FAA review does continue. Could be ready for its first orbital test flight from South Texas as soon as November, but schedule comes with two big uncertainties. Number one is the actual technical ability to get the whole thing sorted and tested and confident. But they're also pending regulatory approval. They test fired the Starship, known as Ship 20 or SN20. SpaceX has moved forward with great speed at Boca Chica. However, the chances of the Super Heavy and Starship vehicles being ready for next month are uncertain. As we all know, Musk often sets aspirational schedule goals, and in September said it wanted to attempt the first orbital launch attempt with Starship within 6 months. Obviously, that didn't happen. So this is a concept of the Starship being lifted up into orbit by the Super Heavy, and I hope this will work. Stand by. We've actually got some exclusive video of a test that they made. Here we are. Stand by caller. Here we are. That was a mock-up of landing on in a Starship. Sorry about that. Okay, over to China, the Shenzhou 13 arrived at the space station for a 6-month stay. So it's a second crewed spacecraft that docked with the Tiangong space station, and they're slated to remain in orbit to twice as long as the Shenzhou 12 mission. So in the crew was the first woman taikonaut, Wang Yaping, to travel the station and first to blast off to space for the second time. Shenzhou 13 spacecraft launched on board a Long March 2FY13 rocket on the 16th of October. And there's also Jiang Xingang, he's the first spacewalker back in 2008, and Wang Yaping, the first female to go to the space station, and Yi Gangfu, the first internationally trained taikonaut. There you go. So it's this fourth of 11 missions set to build a 3-module Chinese space station, and they intend to have that up there for 10 years. Looks very much like a Soyuz, doesn't it? Like Russian space station. The Mir, yeah, the Mir, yeah. All right, so Russian film crew, cosmonauts returned to Earth. Russian actor, director making their first film in space have returned to Earth after 12 days in the ISS. The movie, which is called Challenge, will be the first to be filmed in space, or was the first. Yulia Persilid and Klim Sipenko left Earth orbit aboard the Soyuz MS-18 spacecraft on October the 8th. After 12 days, they left the ISS and landed in Western Kazakhstan. The film, where Persilid plays a surgeon who must rush to the space station to save a crew member who needs an urgent operation in orbit. So this is the whole concept here, the whole backstory is quite interesting. Now, 3,000 applicants were submitted for the main role, number which was reduced to 20 to 30, after which Persilid was chosen. Klim Sipenko lost 15 kilograms in weight to be prepared. He himself will perform the functions of operator, makeup artist and production designer. So he's going to operate the camera. So they launched on October the 5th. The development of the project will be covered within the framework of the Evening Ergonet program, which members moved to the Cosmo a week before launch. From September 12, the first channel, well, I don't know what that is, must be streaming, so there'll be a reality show called The Challenge, the first in space about specifics of selection and training for the project. So this is the crew involved. So we've got Yulia Persilid and Klim Sipenko. So it's Yulia on the left at the top picture there. She is the main subject of the film. She's a surgeon that goes up. Klim Sipenko, he's the director and the film operator, etc. And Oleg Novinsky, who is already on the space station, he's the one that plays a sick astronaut. So, and the other guy in the middle, Anton Sakharov, he was the pilot of the Soyuz that went up to the station. I think a few of the other astronauts or cosmonauts had intermittent roles, etc. So this is, don't read Russian, but this is the poster or the thing for the film itself. So look out for that. I think it's going to be released sometime next year, which will be quite good. And Tom Hanks was not impressed because he was going to be going up to do the first film. Tom Cruise, I should say, yes. So he's not super impressed there. All right. Okay, well, I've actually finished. I love that picture. That's Dawn. I'm not sure whether Joss is still there, but love your work, mate. So
All
people
right.
that, yep.
Yeah, so I've received my Starlink like 2 weeks ago now. So I've just done a pretty short slide deck around the experience and what I've done and where we're at. So I'm part of the Better Than Nothing beta. So let's go through.
Actually, I don't know what's going on, but I'm seeing my screen.
Okay, I'm seeing my one coming up in my feed, so that's...
You are viewing Ashley's shared screen. So, okay, I'm not sure what's going on. Okay, have you got the participants list on the right-hand side?
Yep, I can probably stop your sharing.
Yeah, I thought I had stopped it anyway. Right.
It has stopped for me, so...
Okay.
All right, so let's go through. So I received it, the box, and I've set it up outside quickly, and now I've got it all up on the roof and things. So I've been using it for the last couple of weeks and trying to get a good feel for it. So what is it? So Starlink is a product of SpaceX, and it's a way that they plan to fund their future space ambitions. They're made in the US by SpaceX internally, and so far they've launched just over 1,700 of them, and it goes up to 30,000 later on. So they've been mostly doing it as individual payloads on the Falcon 9, but they also do them as part of extra payloads when they're not quite a full load. So the system consists of Starlink satellites, user terminals, and ground stations. So the terminal is actually affectionately known as Dishy or Dishy McFlatface. So I've done a few videos and things on this in the past, and a few things have changed. So when you're watching videos about it on YouTube, you know that there's a few things that have changed. The most important one being is that it's no longer an ACMA restrictions about where you can actually get them. So now they've got a license to operate Australia-wide, and that happened July this year. And it's no longer a deposit-based system. You just pay the full price up when you're ordering it and it comes in. So you do have some limitations about where you can get it Australia-wide at the moment, because the satellites rely on reflection. So there has to be a ground station within the same area. And the deposit was based off someone on YouTube that I made comments with. So too long to DR for people that don't want to watch the rest of the presentation. So it's a Better Than Nothing beta. So until it's finished, it's out of the beta stage. It could drop out. There could be issues. They could be upgrading networks and satellites whenever they want. But you got no real recourse for that. It's one of the reasons why I'm actually doing my presentation not over Starlink tonight, because it always goes out at the inopportune moment. It's $800 for Dishy at the moment, and $139 a month, and there's no download limits. The speeds fluctuate a lot at the moment because of the minimum number of ground stations and satellites. I've seen between 700 and 300 plus megabits per second for download and 10 to 40 megabits per second for upload. And all of my latencies have been under 49 milliseconds, which is really good compared to other satellite services. They seem to be mapping the obstructions from the dish, so they know when it flies behind a tree, for example, that I'm experiencing. But I guess once they have more satellites, they will then be able to know where those mappings are, so they can change satellites early enough. And at the moment, everything is basically done through the phone app. From site surveys to all of the ordering and tickets and things like that and configurations. So you have to be a little bit tech savvy to have your phone and have that all handy, but realistically you receive it, you connect to the Wi-Fi and off you go. So this is how it works today. You have a ground station talks up to a satellite with 1,657 of them who talk down to a ground station again, which then has access to the internet. So each ground station has a series of ranges that it can see, and each satellite has a range. There's a really awesome website called Starlink.sx, which is a fan-based website where you can see all of these tracking and happening in real time. It's really quite awesome to watch. So they do, the way that the Starlinks are section off is because they don't allow zones and a certain number of people. You get these little hexes. And so at the moment, we're assuming that they have a certain number of people per hex. And if you can see down in the bottom corner where it's gray, that's the areas where there's no ground station that can talk to that hex at the moment. Again, you can see all of this through the Starlink.sx website. So how's it going to work in the future? Well, there'll be more satellites visible for more users. So they'll be able to greatly expand the throughputs of it. You will have, they've already tested Starlinks on aeroplanes and boats, and there are people in America that have just attached it to their car and driven around like crazy people. So that's already kind of working. And then once the satellites can use the lasers to communicate, you'll have multiple redundant paths to the internet, which make it a lot better. And there's already talks with Starlink being put on top of data centers. And that way you'll have, the Starlinks will actually get faster response times to core services than some other parts of the internet. So what was my timeline? Well, I put down my deposit in February of this year. Now, where I lived back then, it was, because Australia did actually have limits of where you could order, I was really on the boundary. So I didn't know whether or not I would actually get it or not. And so when I actually got confirmation I could order, that was there. So all up, I ordered on the 1st of October, paid the rest of the money, and I received it a week later from America. So there I was on the same day. I put it onto a speaker stand and put it outside with the view of the sky. Unlike most satellite services, I didn't need any special tools or equipment to calibrate it. It is quite literally put it somewhere with a view of the sky and plug it in. Not the best spot on my front lawn there, and you can see that I've got some obstructions, and it was saying a dropout every 20 seconds or so. So that's all done through the app. Quite literally, when you plug it in, it has a wireless network and you connect to that and through the app. You can see I took the first screenshot at 5:23 and I was running a speed test by 5:27. So literally 5 minutes start to finish, and getting a speed that was 8 times faster than my NBN wireless was. So I did quite a lot of speed testing. So this was again in that first few minutes of testing. You can see that it did drop out a couple of times because of where it went through the house, and some latency times and speed throughputs. So that one shows a speed of max 302 megabits a second during the testing. So I did get it mounted up on the roof. It seems like they've done their due diligence a bit, and the drilling points in the base stand actually do correlate with corrugated roof. And you can see that picture on the right, on the side there. It's actually mapping the obstruction areas where trees and things are that would cause dropouts. So some highlights of what they've been doing. They've actually already tested it with the US Air Force at flying at speed, so on the Stratotanker. And they've already done and using satellite to satellite relays, but realistically at the moment, they're only doing that for the polar launch that they did a couple of months ago. So once they do have the satellite to satellite comms doing, they'll be able to cover basically the whole world when they do that. So the antennas they use are phased array antennas. So what that means is you're not constantly seeing the satellite track through the sky. It's not tracking a satellite through the sky. So when it's set up and adjusted, it rarely moves. So here's just a couple of speed tests that I've run over the time. Again, you can see a pretty wide varying of numbers there. Some, 350 megabits per second, all the way down to 95 megabits per second for download. So if you get a unit, they ship it to you. The cable comes attached to the Starlink device. You can't remove it. And so you run it through, you plug it into the power device, connect it to their modem, and then you can actually loop that modem onto your own network already. You can also set it up using an existing modem. So if you've already got a pretty good network and stuff set up, you just connect it into a WAN port, like most of the MEN stuff. Apparently they can't hear me. All right. So can you get it? Yes, now it's allowed for all of Australia. It's not designed for people with good internet, so please don't just sign up for it because you can. They'll only be shipping limited units while they're still making it. And there is only some hexagons that they're able to use due to the reflection and ground stations of it. So some people in very regional Australia won't have access to it just yet, but the coverage zones are quite wide. But what you can do now is you can use the Starlink mobile app to scan the sky, get on your roof and look around. And then you can fire up that starlink.sx page and do like a test of your location to see what you can. So you create and do all your ordering stuff through starlink.com. There is some fake ones out there from third parties, so don't use a third party one. They claim to get you it faster and all that sort of stuff. It's impossible. It doesn't work that way. So everything is done through Starlink. So some information that I wish I knew that would have made things a bit easier. The app for surveying is overly cautious. Example, this is from my roof air. It says I'd have a dropout every 37 seconds. Realistically, I have one, maybe two dropouts every 12 hours because of that tree that's blocking it. So the cable from Dishy to the modem things, you can't unplug it or anything. So if you're running it, you have to run it from the roof through the cables and start at the roof and end off where you are. You can see in that top picture that I actually had to cut one of my panels so I could get the cable through because of these ferrite cores that are on it. They're actually quite large, 22 millimeters. So you have to drill bigger holes and things to make it work. They do sell a kit for mounting it through walls, a couple of different ones, but there's no face plates or anything with it. So any installation you do is going to be, I said my one looks a bit dodgy because that's because it is. So when I ordered, they had some roof mounting options, but you couldn't order it at the same time. But apparently I've talked to some people and you can now order them at the same time that you do order. So if you have a particular type of adapter that you need, it will get shipped at the same time. And there was one other thing is that you can access your Starlink at any time using that IP address. That means that you can, see the statistics and things. Because you can use it without their modem, this is how you can replicate the phone app sides. And if you've got multiple internets like I do, you can tell it to send that address over the Starlink, and that way your app will always work for letting you check details and things like that. So there is some controversy around Starlink. They have people, well, particularly in the astronomy areas, are very unhappy with them because at the start and the end of the solar period, there was too much reflections. I think from what I gather, Starlink has been reducing the reflectivity of the units and making that less of an issue. Personally, haven't seen any of the trains recently, but I'm not across that fully. And there's a couple of sources for where some screenshots and stuff came from, and that is the end. So what I might do is I'll let people unmute themselves, and if there's any questions and things, people can ask around.
Corey.
Hi, Julian.
Hey, how you going, Ash?
Yeah,
that
good.
looks pretty good.
Oh yeah, I'm super thrilled.
Yeah.
Yeah, my MBN is pretty bad with dropping out.
Yeah, no, great presentation. Very interesting. But I think I'll hold off because till they get a bit more ground stations.
I was at a presentation the other day for Microsoft for Startup Space that's out there. And the data centers that Microsoft is setting up in Australia actually have Starlinks on them.
Yeah, I wasn't sure which one it was. I thought it was Microsoft that was getting it on there.
Yeah, looks funny. They got this big, huge warehouse, data warehouse, and this little dish sitting on top.
Yeah, right.
Ashley, is that actually a dish or is that the face actually flat?
It looks like a pizza box on top of a pole. It is is the description.
So actually, I know the answer to this question, but the satellites themselves are not in geostationary orbit. So the dropouts you're talking about are as a result of the gaps between the satellite coverage. Is that correct?
Not really. So there's pretty much no longer any gaps between the satellites anymore. It's just the fact that from my rooftop, there's a big row of trees that blocks out, a couple of degrees of the sky. As they get more and more satellites, those will turn up.
So why don't they just send you a chainsaw when you order?
Yeah, unfortunately, they're not my trees. But I mean, realistically, I've just got to put it on a couple of meter high pole now.
Right. Wow. So, like that sort of speed, could you have a consortium of neighbours that could then tap into that and drive 3 or 4 households? Do you think?
Yep, quite easily that can happen. So I'm kind of doing something similar with my neighbours up here now, but realistically for the people in the country, these will be, farmhouses few and far between, or boats few and far between that aren't getting adequate internet service through normal providers.
Right.
How far out in the country are you, Ash?
So I'm down near Phillip Island.
Okay,
yeah,
so there's actually no NBN down there, I take it, is there, or what?
I actually do get NBN at my house here through NBN Wireless, but the problem is that everybody else is also on the NBN Wireless, which means that it drops out and it drops to speeds of 0 megabits per second is my official speed. So I'm not actually allowed to, it drops out and it's got all kinds of issue being regional. So this is going to be my primary internet, and then we're going to have NBN on a smaller data plan as our backup internet. We've had times when NBN's gone down and the phone network's gone down at the same time.
Sorry, Ashley. Ashley, the antenna is, as I understand it, is a phased array. Do you have to orient it at all, or is it basically just flat with the horizon?
No, it's got a series of motors in it, and it self-calibrates.
but it doesn't actually track, does it? It just puts itself into the right position initially. Is that correct?
It puts itself into the right position, and it does reorientate itself if there's like a cluster of satellites on one side of the sky. It does kind of like re-tilt itself so that it gets a better angle on multiple satellites at the same time. But mostly it stays orientated for me to the, I think, the southwest.
So does that continuously then, Ash? Or?
Continuously, yeah. That's all automatic and continuous.
Please, Ashley, you're thinking of putting it on a longer pole, okay? Now, with the circumstances of the weather around, you probably have to have some guy ropes with it as well. Would wind upset the signal?
So we haven't had wind upset the signal yet, even with some of the really big storms that have blown through the last couple of weeks.
Right.
We have, but because it's such a thin, narrow, like UFO, it doesn't have much wind loading. But yeah, we'd absolutely be putting in guy ropes and things. I've got to try and make contacts now that will do that.
Yeah. Okay. Good luck with that. And I'd like to see the final result, but you know, just bursts of wind here and there. I'm hoping it you know, won't upset the quality of the signal.
I said no, it hasn't done that yet. And I've been using it primarily for the last 2 weeks.
Nice. And you know, I think your neighbours will be very, you know, eager to link up with you.
The people at the post office had never seen one before, so I spent some time talking to them. But they'll probably see a lot more of them in the coming months, as a lot more other regional people without NBN or without any good internet at all start to get it.
Did you have to pay customs duty or anything like that coming in, Ash?
No, just normal. You know, that $800 was Australian dollars ordered, you know, in Australian dollars. So it was just shipped, and that must have all been included and done. So
GST included?
Yep.
Okay. Now, what about, like, how far are you away from French Island?
I can see French Island from where I am.
You know, because you know, their communication area is rather limited, right? So are you the same, or are you closer to what you know, the network is for Phillip Island?
Yeah, I'm closer to the network for Phillip Island. But French Island, I know a couple of people on French Island who are definitely looking at it.
Yeah. Because that's always been like you know, a forgotten area for the electricity grid, for the you know, the lighting circumstances, and also the communications networks. You know.
Yeah, French Island doesn't even have mains power, so.
Yeah. So yeah, and that's been the situation I've known for 20 years.
Well, since July, so before July, coincidentally, they were in the high density zone, which prevented them from even signing up for it.
Mm-hmm.
Where I am, it was quite literally that high density zone was running down the middle of our street.
Mm-hmm.
So we couldn't sign up for, well, I figured that if they have any kind of GPS rounding in their limiting license, that we wouldn't get it. But we found out now that since July, they've had full license for all of Australia. So
yeah. What about if you took that dish off your roof and put it in some other location, high up or otherwise? How far away from your modem would it tolerate, please?
So the cable that comes with it is, I think, 35 or 40 meters. It's quite long for the Cat5 cable. You can't detach it, but what you'd end up doing is just plugging it into some other network Ethernet device and moving on there.
Okay, so can multiple users use just the one dish?
Yeah, I mean, it just appears as an Ethernet internet connection, you know, and you just plug it into whatever equipment that you already have. For most people, you could quite literally unplug it, the NBN type connection, and plug this straight into the WAN port, and off you go.
Okay, but can it be multiple households of one dish?
Yeah, you just have to set up your own infrastructure for that.
Especially that Dawn company.
Just be aware, not that you'd ever get in trouble, but I think under the Telecommunications Act, it's illegal to offer any telecommunications services to other people if you're not licensed to do so. So that was in the Act a while ago. I haven't looked for a while. The question is, though, you'd probably never get caught, or no one would ever look at it. But just something to be aware of.
I will make sure I never charge anyone for the service.
Exactly. But I do have a question. Now, my understanding is it's only available to you for you to use at a fixed location. You can't, for example, if you went camping in a remote part of Central Australia, you couldn't take it with you.
Okay, so the only limitation for it at the moment is regards to the hex zone that you're in. It seems to be that there's limits that you can't leave that hex zone. So I think they're like 30 or 40 kilometers wide, so they're quite big. But in terms of the technology, it's not a technology limiter. It's the fact that there's just no ground stations at the moment, like around the central of Australia, and that you'd need to have the satellite to satellite comms. It's something that they've definitely said is going to come. You know, mobile units for people with RVs and things like that, and boats to let them, you know, travel massive distances. But that's not where we're at the moment.
I wonder what the warranty is like on it, because you've got moving parts and everything. Over time, they would need some sort of service or maintenance, wouldn't it?
I mean, they're not moving all the time. It looks quite robust if you watch some teardown videos. But I guess we'll see as that, you know, it's a less than a year old product globally. So I've actually got the second generation of dish, of Dishy McFlatface. There was a previous generation that they obviously fixed some issues with. Like they've put some heaters and stuff in it so that it won't have snow build up on top of the dish. But yeah, it's quite an interesting thing that they're doing.
And dust on Warrior?
Dust?
Dust, yeah, gathering of dust. And
No, it's all sealed, and I doubt dust will worry the radio spectrum on it.
Yeah,
but I guess we'll find out.
Cover it over, that was all, you know.
Yeah,
So,
I mean, it's on a slight angle and it'll get rained on regularly, you know. Well, I guess if I need to, I'll climb up a ladder and spray it off with my solar panels or something. So
yeah, just, you know, say for Central Australia, I thought maybe, you know, the dust prominence would be more critical for them. That's all.
yeah, not sure.
Okay.
What's the furthest distance from a ground station that it will operate?
It's quite a large distance. Let's see if I can bring up. I'll bring up that Starlink.sx page because that's by far the best thing for it. Because you can pick individual satellites and things at that point and know where it is and what it's doing. All right, so here we go.
Message actually go to?
No, I didn't. She's not online. It allows you to send it. It's not online.
I'm actually having to share from a different computer because I'm using this other one for all the live stream and stuff, and it doesn't let you do. It doesn't play nice. So if I zoom in here, so each of these orange dots are ground stations. And the orange dotted line is the satellite talking to it. So you can see that this one here just to the west of Melbourne is talking to a satellite that's coming down towards, you know, the bottom of Tasmania. So it's quite a lot of reach on it. Let's zoom in any further. Yeah. So again, you get quite a lot of coverage.
But my question was, how close to the ground station do you have to be to operate?
Well, quite. At the moment, it's a reflection-based system. So what happens is, as long as you and a satellite, so from the satellite can see the ground station and you can see the satellite, it works, and it looks like it's hundreds of kilometers. Again, so if I was this satellite here, for example, that's talking to the one to the west of Melbourne, you could be anywhere within this satellite's view. Which I don't know if I can zoom out because I don't have a mouse connected to this computer. But yeah, if you have a play around on this Starlink.sx website, you'll be able to see exactly where it is. It's also got a pretty neat simulation feature where you can put in your address, a coverage prediction, and it'll tell you where the satellites and how much outage you're expecting for any given location. But yeah, it's a very, very cool tool.
Thanks.
Yeah. Sorry, Ashley, why wouldn't it be better for you with your dish to hone in on the ground station itself, please?
Well, obviously you can't have line of sight to the ground station.
Okay.
I mean, it's a normal radio link problem. So what you can see is from the roof, it can see the satellite, and the satellite can see a ground station. So that's how you have the communication, because otherwise radios, especially line of sight.
You got your telephone towers, right? And if one of those ground stations was on a telephone tower, then you might be just as easy to hook up with a mobile facility,
Yeah, I mean, if they put ground stations wherever there's going to be fast internet, that's going to be their thing, but they don't need to have ground stations. Like the thing with the mobile phone tower is that's within line of sight. You can see that, and like for example, my NBN wireless has line of sight to the NBN tower. The issue that we have is that it's just congested, and Starlink may end up congested as well if there's not enough satellites and not enough receivers.
Okay.
So
yeah, and your thunderstorms didn't upset your Starlink link?
No, not at all.
Or the lightning and such things?
No, haven't. Well, I mean, I've been operating it for 2 and a bit weeks now. But no weather-related dropouts. So
beautiful. Yeah.
Okay, guys, everyone, it's 9:30 now, so feel free
time for your bed, is it?
Yeah, it's time for my bed, definitely. Feel free to keep going. Actually, I suggest maybe if you want to finish the recording, and then I will go and I'll leave you guys all to have a chat and discuss everything. Just want to say thank you to Josh from Dawn Aerospace. That was fantastic. And we're definitely going to keep in touch with him and see keep track of what they're doing. And thanks everyone else. Thanks for Michael for teeing that up. Michael does a heap of work in the background to get these speakers, and we've already been talking tonight about some of the stuff that's coming up, and it's going to be really exciting. So thanks again for that. Thanks everyone for your support throughout the year. Hopefully we'll be able to meet next month in South Melbourne if you're in the area. If not, please join us online. And I'll say goodnight.
I might